the prosthetic hand project. So basically we're working with some students of engineering at McGill, and we're helping them. We're doing like some experimenting to help give them results so that they can build their hand. So these are just like some pictures of what they have so far. And basically they're using a 3D printer and they're going to be printing this out eventually. And our goal was kind of to calculate like what are the physical limitations of hands, what's the physical limitation of our fingers. So we used a video tracker device.
So what we did is we started by filming ourselves moving our fingers rather slowly and then a little faster. And we used this software called Video Tracker, and what it does is it allows you to place a point on each frame of the video where the finger is actually located.
Alright, hi, my name is Caleb. I'm a health science honors student here at Vanier College, and this is an experiment myself and a few honors science students did. What we basically did is we partially sequenced a gene in a few plants, and we sent that data to essentially a resource center of information in order to ensure that the information we got was accurate. Some challenges we faced was that some of the instruments we used during the experiment were fairly new to us. We didn't know how to use them at the start, but throughout the experiment we got familiarized with the instruments, we learned to be precise, we learned to be patient, and at the end of the day we produced a really well and explained result.
Hello, I'm Ariana Elias. I'm a student at Mircea Cel Bătrân National College in Constanța, Romania. We have come here in Canada to present you our project Euxinis, the island. We designed this eco-friendly artificial island. Its name comes from Pontus Euxinus, the ancient Greek name for the Black Sea. It is located in the western part of the Black Sea, naturally. Why we wanted to build this island? Because we want to exploit and explore the eco-friendly resources. We want to use solar energy, wave energy, the sun energy, and what we focus on is hydrogen sulfate, because there are large amounts of hydrogen sulfate in the Black Sea.
My name is Chris, and
I'm Jason.
And we've built a device capable of harnessing the wind for producing green energy that is sustainable. The way this works is the whole concept came to me whenever we were walking around Vanier, and we have a graph here that actually explains it. As you can see, the wind speed doesn't drop down to zero very easily. So what we thought about is using this natural wind tunnel found in between two buildings, for example Vanier and the church on Saint Croix, and using this whole idea of pressure drop to actually control it. What this does is the anemometer in the front senses the wind direction as the wind enters in between the gaps of the buildings. What this does is it senses it, sends information to the Arduino right there on the side, which calculates the proper information that it needs and sends an information to there's two servo motors in the back. What these do is control the walls, open and close them. When the wind is so slow, the walls are closed, as you can see right now. But as the wind increases, the walls will open to slower the wind speed in the back to maintain the same wind speed where the propeller should be. This allows us to produce sustainable and useful electricity.
Hi, my name is Michael Pratt. I'm in health science, and this is our project on photosynthesis and fluorometry with the Vanier. Basically what we did is we analyzed the photosynthetic efficiency of plants growing under different conditions, such as a cancelled magnetic field and a cancelled electrical field, as you can see. We discovered that cancelling weak magnetic and electrical fields, such as those present on the Earth, actually had very negative effects on the growth of plants for a variety of different reasons. Most notably because when you cancel an electric or magnetic field, you change the orientation of many molecules inside of a chloroplast in a cell in a plant, so it had very negative effects. So this was a very interesting project because it helped us better understand plants and how photosynthesis works and some different parameters that may influence their growth.